The p-value is a very useful tool in statistics because it tells us the conclusion to our tests. Now, depending upon what sort of test you're running, left tail, right tail, or two-tail, you're going to do a slightly different manner of actually calculating a p-value. So if you have a left-tailed test, what you do is you calculate the area to the left of whatever the test statistic is. That will tell you the level of alpha necessary to reject the null hypothesis. So any level of alpha that is going to be larger than that area, the p-value, and you will reject. Anything smaller and you would fail to reject. If you have a right-tailed test, then you just go to the right. Even if you're well on the left of the distribution, you find the area to the right, and that is any alpha that is going to be greater than that would make you reject the null hypothesis. In a two-tailed test, what you do is you figure out which tail you're closest to. So if your test statistic is positive, you find the area to the right. If it's negative, you'll find the area to the left. Then you must double that because, as you know, we cut the alpha level in half. So you're going to have to double whatever that area is, and that will become your p-value. This is the rule. If your p-value is less than or equal to your level of alpha, reject the null hypothesis. If it's bigger than alpha, you're going to fail to reject. So now, these are the three different types of hypothesis tests that we did. These are the three different test statistics that we used. Now these are the three calculator functions that you can use to produce the test statistic along with the p-value. As we found with confidence intervals, we use the stat key, arrow over to tests, and then we need to find the value. Now, before we were looking for things that had int or interval in it. Now, since we're doing tests, we want something that says test, and all of these do. So a large sample test for the mean mu is a z, so it's a z-test, and that's actually the first option. Small sample for mu is a t, so it's a t-test. As I said before, anything that deals with p has a prop in it. We have one sample, so it's one prop z-test. It's a z-distribution. Alright, let's see if we can run through a few of these examples that I did before and calculate the p-value. First of all, I just want to do this one and find the area and calculate a p-value strictly without the actual ease of the test, just to show you how it works. So our test statistic was 1.666, or about 1.67, so right about here. Okay, so there's our test statistic. So the area to the right of that, since it is a right-tailed test, this is the p-value. And let me write this 1.67 in. Remember, this is our test statistic. This is not a critical value. So the area here, the area to the right of this 1.67, is going to be the level of alpha that you're going to need to reject the null hypothesis, or anything above it we would reject. So to calculate the area of a z distribution, we need the normal CDF. So second vars, the normal CDF is here. We need to give it a lower value. In this case, I'll just put in the whole thing, 1.66, make it 7, whatever. And the upper is our E99, so second E99. So the p-value here is 0.0478. Now when doing analysis with this, we compare the p-value to alpha, which is 0.05. It is less than alpha, less than 0.05. So our conclusion is reject. Now for the two-tailed test, again we have 1.67. is about here. And we're going to calculate that area. However, we're going to have to double it because it's a two-tailed test and you're going to be cutting alpha in half. So the p-value here is going to be the area we just found times 2. So the p-value for the two-tailed test is 0.0955. This is not less than alpha, so we fail to reject. Now, as I mentioned, the calculator function, in this case Ttest, will calculate the p-values for us. So let's take a look at that. So stat, tests, the very first option is Ttest. Similar to the confidence intervals, we have the option of going with data or statistics. We don't have any data, we have just the statistics, so we're going to enter those in. What mean that we're testing here, that's mu sub 0, that's what our proposed value is, and that is 100. Sigma in this case is 60, and x bar is 110. N was 100, and for the first one we're going to test greater than. This is very important. Which of these three you choose will tell the calculator how to calculate the p-value. So for the first one we're going to leave it at greater than, and we're going to hit calculate. So the two things of import that come up is the z-value, the test statistic, and the p-value. So there's our p-value there, 0.04779, so 0.0478. That is less than alpha, less than 0.05, we reject. Okay. We can run the same thing, and all we're going to do, all we're going to do is change this to doesn't equal. Everything else is already inputted. We don't need to do it again. We're going to change it to doesn't equal, and the only thing that should change on that display, well, there should be two things. One, before this said greater than, this tells you what test you ran, but the p-value is the main thing that's going to change. The test statistics is the same for all three of them. The p-value is now 0.0955. Now it's greater than alpha, so we would fail to reject. For the t-test, it's going to be the same basic process. Stat tests, only we use t-test. Again, this is a mean, n is 20, which is less than 30, which is why we're using the t. So we fill in the information. The proposed value, mu sub 0, is 50. X bar is 45 at the top. S of x is 8. N is 20. And we're doing specifically less than, so we're going to highlight the less than. There's the test statistic we got before, negative 2.795, and our p-value is 0.00577, or a very, very small number. So in this case, we are going to reject. Again, any value of p less than alpha, alpha is 0.05, we will reject. Okay. Now, keep in mind, if you get conflicting answers or conflicting conclusions on your p-value and the classical method, which is what I did before, which is compare the test statistic with the rejection region, then you've done something wrong. Something's going on in the calculations. They both need to give you the same answer, the same conclusion. And finally, this was the proportion test we ran. We're looking for strictly greater than, so stat tests, 1 prop z test, number 5. There's one proportion, and it's a z test. The proposed value is 0.46, x is 525, n is 1010, and we want greater than, so this needs to be changed. There's your p-value. Now notice it's 6.8. This p-value must be, since it's an area, must be a value between 0 and 1. So clearly there's something else going on. We need to look at the scientific notation. E to the negative 5 means that the p-value is got 4 zeros in front of it, so it's 0.0000685. So 0.0000685 is less than 0.05, which is alpha. So therefore we reject. And that is how you use the calculator to find p-values along with the test statistic information to run hypothesis tests.